All right, let's move on our review. Let's take a look at problem number 5. It says assume the value of the painting increases over time linearly. After 3 years, the painting was worth $227. After 6 years, the painting was worth $395. Find a linear function that expresses the value of the painting with respect to time. So it's a function of time. This painting increases in value over time, over each year, right? It's producing a new value. So with that said, what's the average rate of change in the painting per year? So with that, they're asking us to find the slope, right? We just got done talking about slope. That's your average rate of change between any 2 points. So we can come up with 2 data points that describe the value of this painting from year to year, right, which we were given here at the beginning. We'll be able to calculate that slope. So what is the initial value of the painting? All right, so what will the value at time t equals 0 be? And what will the value of the painting be after 10 years? And when will the value of the painting reach $507? So let's take a look at this problem. We're trying to create a linear model, a linear function with respect to time. So again, with that said, we're looking at creating a model, again, of slope-intercept form, y equal mx plus b form. So that means we're going to try to calculate the slope, right? We need to find the slope, right? We need to find the value of m, and then we'll find the value of b, right, in that order. So we're trying to calculate this linear model. So let's go ahead and do that. So let's think about these couple points. So we go back to the first or second sentence. It says after 3 years, the painting was worth $227. So let's go ahead and write that down. So after 3 years, all right, painting, right, worth a value of $227. So that implies what? That implies we have a data point, right, an x value. Again, remember it's going to be a function of time, a function of x. So we're going to x represent the year. So year 3, and we have our value of $227. So our output, right, will be the value of 227. And again, that's our data point. So let's write down our data point, our value of x and y, again, our ordered pair. And we got our second point. It says after 6 years, right, as we read on in this problem, after 6 years, the painting held a value. It's increased, right, to a value of $395. So after 3 years, $227. After 6 years, $395. So there's a second data point, right, that we can use to define this value of the painting that we're looking at. So let's go ahead and calculate the slope. So finding the slope, right, the value of m, right, your change in y, right, your rise over your run, the change in y over the change in x. Right, well, we're dealing with what? Our 2 data points. We got, again, x and y. So we got our y values, right, 395 and 227. So 395 minus 227 divided by the change in the x values, which is 6 minus 3. And that simplifies down to 168 over 3, which is equal to 56. So there's our value of m, right? There's our slope, which just represents what? $56 per year, right? Remember, this is value over time. Changing y is the value of the painting, and the x value is the year. So again, it's calculating slope. So we can now look at what? Creating our line, our linear model. Y equal mx plus b. Y equal 56x plus b. So now we need to go ahead and calculate, right? We need to go find b. All right, so to find our value of b, right, what we're going to do is use our data point. So to find b, let's go back to one of the points that we were given. So let's take the data point of, I'll use the first one. After 3 years, the value of our painting, was $227. All right, so that implies what? We can plug that in. So that implies y, 227, is equal to 56 times x, which is 56 times 3, plus b. So we can go ahead and simplify and solve for b. So 227 is equal to 56 times 3, which is 168. So we do our calculation. As we solve for b, so we go ahead and subtract 168 over to the other side of the equation. We get our value of b, which is what? 59. So 59 is b. Now b, again, represents the y-intercept of this linear model. So now we've got m, and we've got b. So that implies our function, we've got y equal to 56x plus 59. So there's our linear model. So as we go back to part A, we just created our function of x. So again, y, which represents the value of the painting, x represents the year. So let's go ahead and write our function. I'm going to use a function name like v, the value of the painting after 2 years. So v of t is equal to 56x, right? So that's $56 per year. That was our rate of change, our slope, right? So we want to write that in, our slope value. We can go ahead and do that. All right, plus the value of b, which is 59, right? And that's the initial value of the painting, right? So that's going to lead us to other answers. So part B says, what is the average rate of change? Well, the average rate of change is our slope, right? It's 56. So again, that's $56 per year. That's the rate at which it's increasing from year to year, our painting. So again, remember, that's our rate of increase. So again, we're calculating that slope. We're finding that value. Now let's go on to part C. Part C says, what is the initial value? So the initial value, right, would be our value when x equals 0, right, year 0. So our initial value, which is x equal to 0, right, that produces our y-intercept point. So that's going to equal the y-intercept. Well, the y-intercept was 59, right, our value of b. So $59, right, will be the initial value of this painting. Let's go to part D. Part D says, what will the value be after 10 years? So value after 10 years, let's go ahead and calculate that. Well, that implies what? Finding V of 10. So value after 2 years is 56x plus 59. So the value after 10 years will be 56 times 10 plus 59. So as we simplify down, right, we get 560 plus 59, which is equal to 619. So $619, there's our value after 10 years. All right, so let's go to part E. It says, when will the value be $507? All right, so our question here is, when does V of t equal 507? So we got to set up a linear equation to solve. So V of t is 56x plus 59 equal to 507. As we solve that, we got to go ahead and subtract 59 over. So that implies 56x is equal to what? 507 minus 59. And as we subtract that, we get 448. So 448. And then we'll divide out our coefficient of 56 on both sides, which gives us a value of 8. So when we just found x, right? That implies x equal 8. So again, it's going to take what? 8 years. 8 years for our painting to reach a value of $507. So again, creating a linear model, right? We had to find the slope. We had to find the y-intercept, right? Linear function, slope-intercept form, y equals mx plus b. Calculate that slope. Get you a couple of data points. We can calculate that average rate of change. Then we can plug in either the given data points, right, to find B, and we've got our model, and we can use that to answer our questions. So moving on, let's look at problem 6. We're going to review the difference quotient. The difference quotient is derived from our definition of slope. This is where we define the slope of a secant line. And the slope of the secant line, right, the secant line is your line passing through 2 points on a given curve, right, on a graph of a function, maybe it has a curve in it. We can take any 2 data points on that and draw the line passing through those 2 points. And we can find the slope, right, the rate of change from point to point. That's the average rate of change on that interval of values, right, on that function that we're looking at. And that's where this difference quotient is derived from, right? It's taking 2 points, taking the point, looking at x on the x-axis, moving over to x plus h on the x-axis, and producing the outputs f of x plus h and f of x, find the change in y or change in x, will produce its quotient. So we're given the quotient to work with, so we got to calculate it. Now to do that, our first step always in calculating the difference quotient, right, is to find the missing part that we need for our quotient, which is f of x plus h. So we're given f of x. Let's go calculate f of x plus h. So f of x plus h would be equal to, well, if f of x is 7x squared plus 5, f of x plus h is 7 times x plus h squared plus 5. So let's go ahead and simplify that down. Now we square x plus h. We're multiplying x plus h together 2 times. We got to expand it. And then we need to go ahead and distribute. Right, as we distribute, right, we're going to FOIL out or multiply these 2 binomials together. And if you want, we can keep it in brackets. Go ahead and draw some brackets around that. We'll go ahead and square it and then multiply the 7 through. So as we work on inside the parentheses or inside the brackets here that I've drawn in, right, what do we get with the square of x plus h? X times x is x squared. X times h is xh or hx. Doesn't matter the order you write it in. H times x, which is the same product. I'm going to write xh here, same order. H times h is h squared. So you can see the product, right, that we've taken here. We see the square of x plus h here. So let's go ahead and simplify inside the brackets, and then we'll distribute our 7 through, and we'll have the value of f of x plus h. So let's go ahead and simplify first before we distribute. So inside the bracket, we've got a couple of xh terms. So we end up with what? X squared plus 2xh plus h squared, right, plus the 5. And now we can clear out the bracket. Now we'll go ahead and distribute. So we'll multiply that 7 on through. So that equals 7x squared plus 7 times 2xh, that's 14xh. 7 times h squared is 7h squared plus 5. So there it is, simplified down. That's as far as we can take it. But there's the value, right? Here's f of x plus h. So as we calculate the difference quotient, we're ready to do that now. So the difference quotient, I'll call it dq, is equal to f of x plus h minus f of x, all divided by h. So let's plug in what we have now. So f of x plus h, which we just calculated, is 7x squared plus 14xh plus 7h squared plus 5, and then minus f of x, which is 7x squared plus 5. So again, there's the value of f of x plus h that we calculated at the beginning. Here I am plugging it in to the numerator of the difference quotient. Remember, we got to find f of x plus h minus f of x and then divide all of that by h. So let's go ahead and simplify. So my next step, we need to go ahead and distribute. Let's go ahead and distribute and clear out these parentheses. So 7x squared plus 14xh plus 7h squared plus 5 minus 7x squared minus 5, as we clear out the parentheses with the minus f of x. So we distribute the minus to both terms. As we do that, what happens? So now you notice the numerator starts to simplify nicely. We got the 5 and the minus 5. They cancel out. We got a 7x squared and a minus 7x squared. They add up and cancel out. So in the end, all we're left with is two terms here in the numerator. 14xh plus 7h squared, all divided by h. And let's simplify that down. I'm going to go ahead and factor. So I notice that we have a h in both, so let's factor that out. Let's factor, so we have a GCF, factor out h. So as we do that, the numerator is h times 14x plus 7h, all divided by h. And then by factoring the common factor out, we have a common factor of h showing up in the numerator denominator. So they divide out, and our difference quotient simplifies down to 14x plus 7h. So there's the difference quotient. So again, the work was at the beginning. Step 1, finding the value of f with an input of x plus h. So we were given f of x, this quadratic function, to work with. Right, went ahead and found that, and then we were able to plug it in, right, and do our work. So let's move on. Let's go to another application here of talking about slope. All right, here's a quadratic function again. F of x is negative 3x squared minus x. It says for this function, find the average rate of change between the given values. So from x equals 5 to x equals 6, what would the average rate of change be with this function? So let's go ahead and find these two function values. So x equals 5, let's start with it. All right, so that implies what? F of 5 is equal to negative 3 times 5 squared minus 5, which is equal to negative 3 times 25 minus 5, which is negative 75 minus 5, which is negative 80, right? As we simplify that down, now that's the value of f with input of 5. So that means when x is 5, right, we have an output of negative 80. So there's an ordered pair, a point, right? There's x, there's y. Well, let's do the same thing here with 6. So as we look at x equals 6, all right, what happens? Well, the value, the output for that, f of 6, will equal to negative 3 times 6 squared minus 6. So let's go ahead and simplify. So I got negative 3 times 36 minus 6. All right, so let's go ahead and simplify that down. And what's negative 3 times 36? Well, we get negative 108. And negative 108 minus 6, that's negative 114. So f of 6 equal to negative 114. So again, there's my output, my y value. So that means we have an ordered pair. When x is 6, y is negative 114. So here's, again, x and y. So the average rate of change, let's go calculate that. ARC, right, equal to our slope. y2 minus y1 over x2 minus x1. So change in y, so let's plug that in. So negative 114 minus negative 80. There's the difference in the y coordinates over the change in the x coordinates, which is 6 minus 5. As we simplify, it gives us negative 114 plus 80. So we subtract negative 80, becomes a plus, divided by 1. And what does that simplify to? So what do we get with negative 114 plus 80? So as we combine those, right, as we look at our last work there, so negative 114 plus 80 gives a value of negative 34. So there it is. There's our average rate of change. Negative 34, right, is the average rate of change from x equals 5 to x equals 6. So negative 34, right, be our output. So again, finding slope, calculating that slope value, right, in our problem, finding the average rate of change between the given values, right? Moving on, let's continue our topic looking at some algebra functions. Here on the next page, in problem number 8, it says for the pair of given functions, find the indicated difference. So here we want to find f minus g of 5. All right, so they give us f of x, and they give us g of x, and they want us to calculate f of 5 minus g of 5. So they want to subtract these two functions with an input of 5. So let's go ahead and do that right here beneath it. So what would f of 5 be? Well, if f of x is 5x squared plus 1, f of 5 is 5 times 5 squared plus 1. There's the value of f of 5. Minus, what's g of 5? Well, if g of x is x plus 7, g of 5 is 5 plus 7. So as we simplify, we get 5 times 25 plus 1, minus 5 plus 7, which is minus 12. 5 times 25 is 125, right? And 125 plus 1 is 126. And 126 minus 12, we get 114. So 114, there's our difference function with an input of 5. So that equals f minus g of 5. So again, they're giving you an input, right? They're giving you a value of x to plug in as we do the algebra. All right, let's do another one similar. That's for the given functions f and g. Now in these two, we got two rational functions. It says find the requested function and state the domain. So we'll add on to it a little bit. Find the domain of f minus g of x. So what's f minus g of x going to be? Well, that's equal to f of x minus g of x. So we're going to take the f function, which is 3 over x plus 5, and we're going to subtract the g function, which is 2 over x. Well, as we subtract these functions, all right, I want you to go ahead and note, right, one thing that we need to take care of is, are there any domain restrictions on these functions we're using to create? So we can go ahead and take that note in this problem. So we know, for example, we know x plus 5 cannot equal 0. So as we solve for x, that implies x cannot equal negative 5. So there's one domain restriction, along with x cannot equal 0. So make that note before you begin, right? There's two domain restrictions. We got to get rid of 0 and negative 5 because they make the denominator 0. So remember, domain, we can't have values that, again, don't give us an output, right? We can't have undefined values, right? Domain are all the real number values of x that satisfy our function. So those are two that don't. Now, we might produce a new one in the end, but we got to take care of the original ones first. Now, how do we subtract two rational functions? Well, if we're going to subtract these, we're going to do the difference. We need to get a common denominator. So let's go ahead and rewrite both of these with the LCD. So the LCD would be the product of these two denominators, right? The product of all your different factors that show up. So as we rewrite these, right, let's go ahead and rewrite them with the LCD in mind. So we're missing an x plus 5 here on this one. So again, we're missing x on the first one. So I'm going to go ahead and multiply by the missing factor that will make that LCD. As we do that, what do we end up with? Well, we end up with 3, right, times x, which is 3x, right, divided by, and we write it out here now, divided by x plus 5 times x, right? And then we got minus, right, 2 times x plus 5. Let's go ahead and write that down here. We'll put it in the same color. All right, divided by our LCD, which is that denominator of x times x plus 5. So let's write it and we'll keep it in the same color. The x times the x plus 5. All right. So now we can combine them together into one. So we've got them rewritten with a common denominator. So as we combine these together into one fraction, we have our LCD of x times x plus 5. Well, our numerator, we have 3x minus 2 times x plus 5. So combining the two numerators together. And let's go ahead and simplify. So go ahead and distribute. So that gives me 3x minus 2x minus 10. we distribute the minus 2 through, divided by x times x plus 5. And of course 3x minus 2x makes x. So we end up with x minus 10 over x times x plus 5 as we simplify that down. So again, you can see your difference function. Now, does that denominator produce anything different as far as restrictions? No, we still can't divide by 0 or negative 5. Same two factors involved. So we do have the difference function here in front of us. And we'll leave it like that in factored form. But we can also go ahead and talk about domain. So domain, again, all the real number values of x that satisfy our function. So let's take a quick look here, if you want to write interval notation. We know negative 5 and 0 are the undefined values. So all real numbers except those two. So our domain in interval notation equal to negative infinity to negative 5, union negative 5 to 0, union or 0 to infinity. So there's a list of all the real numbers that are going to satisfy this function as we look at that one. So again, that's finding the difference function. All right, let's do one more. Let's go to problem number 10. In problem number 10, we're given f of x and g of x. Now, f of x is a degree 4 polynomial, and g of x is a even root, power 4, and then a root 4. Now, f of g of x, so you'll notice the notation. This is composition. This is equal to f circle g of x. Open circle means composition. So they're wanting us to do composition on this problem. Now, composition is all about substitution. So as we find f circle g of x, which is equal to f of g of x, right, we're looking at f evaluated with an input of the fourth root of x minus 3. Now, one thing you want to talk about with domain, you've got to look at the domain of your input function. So we do have restrictions. With a even root, remember we cannot have negatives. So remember that x minus 3 must be greater than or equal to 0. So as we go ahead and solve for x, we can go ahead and mention some restrictions on our domain variable. So x is going to have to be greater than or equal to 3. So keep that in mind. This is a domain restriction. Now, what do we get when we evaluate? Well, let's go to the f function. So here's where we substitute. It's only one x term, so we're going to take g of x and plug it right in there. We're going to substitute it right into the f function. So that'll be 2 times the fourth root of the x minus 3 raised to the fourth power plus 5. And as you simplify, well, fourth root raised to the fourth power, that eliminates. So we end up with 2 times x minus 3 plus 5, right? We eliminate that altogether. Well, as we distribute, we'll clear the parentheses, we get 2x minus 6 plus 5, and then we go ahead and combine the constants. That's 2x minus 1. And there it is. There's our composite function. There's f composed with g. So there's f of g of x, right here, 2x minus 1. Now, as our domain goes, no new restrictions out of this new function. This has got a linear model, so no undefined values. So our domain, let's go ahead and write it out in interval notation. All right, all the x values that satisfy this function, x greater than or equal to 3, be a bracket on the 3. We got to include it all the way to infinity. All right, so again, that's the algebra of functions. So that's a good stopping point. We'll take a break and continue.